4 gram of a gas occupies 22.4 liters at NTP. The specific heat capacity of the gas at constant volume, that is CV, is 5.0 joules per kilomole. If the speed of the sound in the gas at NTP is 952 meters per second, then the heat capacity at constant pressure is taken gas constant R is equal to 8.3 joules kilomole. Same. The number of mole is given as 1. That is 1 mole they are going to given here. 1 mole they are going to concentrate here. The molar mass of the gas, that is M, is equal to 4 grams. In terms of kg, this is 4 into 10 to the power of minus 3 kg. The speed of the sound in the gas is given by V is equal to under root of gamma RT divided by M, and squaring on the both sides, we get V square is equal to gamma into RT divided by M, because the square root and the whole square, the root and square will get cancelled. And by substituting the values, that is a V, they are going to given this value is 952 into 952 whole square is equal to gamma into R value is given as 8.3 into net NTP, that is a 273 divided by 4 into 10 to the power of minus 3. By solving, the gamma is equal to 8 by 5. Thus, gamma is equal to, we know that is a Cp by Cv, that is equal to 8 by 5. Given Cv is equal to 5 joules per kilomole. Cv is equal to 5 joules per kilomole. Then we get the value Cp is equal to 5 into 8 by 5, which is nothing but 8 joules per kilomole. Then the answer for this question is option B is the right answer.